As we begin Math 098, Chapter 4, Systems of Equations, we're going to start with solving linear equations. So that means we're going to solve two lines. That's a system is two or more. And what we're going to do is find a value for the equations that make both two or more equations true. So remember, solving means finding a value for a variable. I'm just going to type it out. To make the equation true. Maybe I should bold that in a different color. There we go. Now we have three main ways of solving a system: graphing, substitution, and elimination. And as we learn these, I'm sure you'll remind yourself on how you did each one of these. Well, the first thing that we're going to do is just double check that the ordered pair is a given solution for the system. So as you recall, I know this looks weird, but there's supposed to be a brace over here to say, hey, here's our system. And then what we're doing is we're testing if this point is the correct answer. Now remember, it's an ordered pair, so if you think of it graphically, we always write x first and then y. So all you have to do is double check. Now, in order for it to be true for both, it has to work for both. So as soon as it does not work for one, the answer is automatically no. So let me just color code slightly. The top equation I'll just do in this color. So it's the negative of 3 minus 4 times negative 1. Well, as you simplify that, that's negative 3 plus 4, which equals 1, which is exactly what it said. So maybe put a check mark that says, hey, that's good. So then move on to the other equation. So we're doing plugging 3 in for x, plus negative 1. Okay, so that's 6 minus 1. All right, that equaled 5, which that's what it was supposed to. So is this ordered pair a solution? Yes. So it has to work for both. So as you look at the next one, maybe I'll just do this all in one color. X is negative 2 now. Y equals 4. If you like, the one that kind of screams out at me is this one. Kind of looks like a weird statement. Well, let's see. If we plug in negative 2 for x and 4 in for y. Okay, so that's positive 2 plus 12, which equals 14. Oh, it was supposed to equal 8, so that is false. Maybe put an x right there. And if this one is false, don't even bother trying the other one, because the answer is automatically no. There we go. Again, feel free to pause the video at any point and confirm your answers. So as I scroll down to show you example 2, they want you to practice solving by graphing. Now it's up to you how you want to graph. Most of my students in the past have changed everything into slope-intercept form. So if I rewrote that, negative 2y equals negative 3x plus 4, and divide everything by 2, negative 2, excuse me, that becomes positive 3 halves x. That's an ugly 4. Don't judge me. 4 divided by negative 2 is negative 2. So if I were to look at the graph of that, I would start down 2. That's your y-intercept. And then it's up 3, right 2. Now I don't know where they're going to cross, so I might go up 3, right 2 again. And I might go backwards, down 3, left 2. Alright. So just to keep the same color going. Oops. Alright, so let's look at the next equation. Most people would probably look at that, and so add 9x to the right side, and then divide everything by 6. Now try to reduce when you can. Okay, because as I reduce that, that's 3 halves, both those divided by 3, minus 2. Okay, so if I were to graph that, I would start down 2 again, and I'd go up 3, right 2, up 3, right 2, and also backwards, what do you notice is the two lines are identical. So what does that mean of this system is this line is the correct answer. And so we would use the phrase that there are infinitely many solutions. Every point that's on the line works for both equations because that's where the two lines intersect, everywhere. To give you a few more words that the book uses, if you check with the back of the book, they might use this phrase that we call this consistent. It's a consistent system. Or you might see the phrase dependent equations. So the answers sort of depend on each other. But you're going to see me use infinitely many solutions. Every point on that line is a solution to that. So because I want to write it that way, I'm going to scroll back up. I just wanted you to be aware if you ever check with the back of the book. Alright, so let's look at the next one. So let me get my axis on here. Just as a reminder, it might be helpful for you to write this top equation as plus 0. So you know that starts at the origin, goes up 5, right 1 as your slope. You can also go down 5, left 1. This is very bright of a screen color, but hopefully you're okay with that. And then with the second equation, I would probably rewrite it as y equals negative 2x plus 7. So you would start up 7, and then down to right 1. Oh, look, there's our point of intersection. So this is the point we're looking for, and that's the ordered pair 1, 5. So what that means is, and this is your answer, so that means that your solution is x equals 1 and y equals 5. I just like to write it as an ordered pair, and I would also, it might be good practice for you to double check your work. Is it true that when x was 1, y was 5 in this equation? Well, yeah, 5 times 1 is 5. What about this one? Let me switch back to that other color. When x is 1 and y is 5, does it still equal 7? Well, yeah. So this is the only solution. We're looking for point of intersection. So there's one solution. Again, you don't have to write this down, but I wanted to explain that real quick. But I did want to mention that, because your book also talks about this, is when there's one solution, they call it a consistent system, but this time it's an independent equation. Like the answer equations, you'll get an answer is basically what they're saying there. But again, I don't use those phrases that I typed out. And then the last one for exercise 2, I would probably just go ahead and graph the top one because it's already in the form that I like. So starting up 1 and then up 3, right 4. Because again, you don't know where they cross until you draw both of them. So it might be to your benefit to draw up and back, down 3, left 4. Alright, so this is the top equation. Looks something like that. And then the bottom equation, I'm going to do in this color, I would probably add 4 to the right side and subtract 12 to the left. It's just how my brain works. So then as I solve for y, I just have to divide everything by 4. 3/4 is x. 12 divided by 4 is 3. So this time I'm starting down 3 and then going up 3, right 4. Well, what do you notice about these two lines is that they're parallel. And what does that mean if they're parallel? They never intersect. I'm going to use my symbol for intersect. We learned that earlier this year. But what does that actually mean is that there's no solution. There's no point of intersection. That's what you're going to see me write, and what would be on a test. I would expect to see that. But for anybody that's curious, the book also calls this an inconsistent system. And these are independent equations. Okay, so go ahead and pause the video before I move on to the next. I'm going to do exercise 3 as well. And I'm going to show you how to use Desmos. So you could have done any of these with Desmos, as long as you have an internet connection. That is perfectly fine. Alright, so let me pull up Desmos, and hopefully you already wrote down the equation, although I'm about to anyway. And what's nice about Desmos is you don't even have to solve for x, except I wrote the wrong thing. So you have that linear equation, which is the same thing as adding 0.25 to the right side, which is 1/4, which kind of looks like it's up 1, right 4. And then the second equation, which they give you as y plus 1.03x equals negative 5.1. So what we care about is where the red curve and that blue curve intersect each other, which is right there. There's really no other math to do. Just double check that you typed it in correctly, which is what I'm doing right now. And then this is your final answer. So back to my notes. We just figured out that x was negative 5.2. I know it says 2 decimal places, but I think you know me by now. I like 3 decimal places. 234. And 0.291. Alright, make sure you pause the video before I end it, because I'm going to move on to a new video.